Welcome to Biology My Passion. I am Soumya Harikrishna. We are learning the chapter Metals and Non-Metals. Today we are coming to the last part of the chapter about corrosion and ways to prevent corrosion. When a metal is kept open, it will be attacked by the substances around it. It can be air, moisture, acid, etc. Such a process is called a corrosion and the metal is said to be corroded. When metals are forming an oxide layer, actually it is a protection for it, but that is preventing it from further corrosion. So there are different metals undergoing corrosion when air and moisture are present around. The maximum corrosion that we are familiar with is about iron. Iron undergoes corrosion and that process we call it as rusting. Rust is actually a brown flaky substance forming over iron. Its formula is Fe2O3.XH2O. Here number of water molecule is not fixed, that's why we are giving X there. And it is called a hydrated ferric oxide. So once iron is rusted, it will become brittle and it's not that strong. Then the second is copper. Copper and silver are metals which can undergo kind of corrosion. There it is not called rusting, but they are developing a color change that's called a tarnishing. So copper develops a green color coating over copper, that is called that is due to the presence of basic copper carbonate, that is CuCO3.CuOH twice. And also silver forms a black coating over it when exposed to the conditions, and that is silver sulfide coating. This is about corrosion. You know that corrosion is having one advantage, that it prevents further damage of the metal, whereas it has got lots of other side effects also, because lots of damage happens to the iron articles over a period of time, or copper, and also it causes huge loss for the country. Now, what are the ways to prevent corrosion? We can prevent corrosion by different methods. Some are temporarily. Suppose you have an iron article, you just have to give a coating of paint or greasing or oiling over it so that there is no direct contact with the air, so we can prevent corrosion. But once the coating is over, again there is a chance of corrosion. Then another one is chrome plating. We are giving a chromium plating to the iron articles to protect it from corrosion. Then anodizing. Anodizing is giving a thick layer of oxide over the articles like aluminium so that we can prevent further corrosion. Alloying is a very good method of preventing corrosion. Alloying is mixing a metal with the other substances. We will learn about it in detail. And last is galvanization. See, whenever more reactive metal is there in contact with a particular metal, you know that the more reactive one will be undergoing reaction, so the less reactive one will be protected. So for protecting iron articles, usually we give a coating of a more reactive metal like a zinc over it. So whenever there is a chance of corrosion, who will undergo the corrosion? The zinc will undergo the corrosion, leaving the iron back. So iron is protected. It's just like a bodyguard. As long as I am over iron, nobody will dare to touch iron. That is the way of action. So zinc will protect iron from corrosion by undergoing corrosion itself. Now, so these are the methods that we are telling, and now in your textbook there is an activity given to prove what are the factors needed for corrosion to happen. So there are 3 test tubes. In the first test tube there is water. In that water iron nail is dipped, and above the water level there is a column of air also. So both oxygen and water are present, moisture present, and we can see that water, if you consider also dissolved oxygen is in water. So since air and moisture are present, there is a chance of corrosion. Whereas in the second test tube, there is no air available to the nail. Why? Because over the water level, there is a layer of oil which will separate the water from the air column above. So air will not dissolve in water. And to prevent the air in water, they have taken distilled water which is boiled. After boiling, there is no air present, oxygen present in it. So here what is available? Water is available, but there is no oxygen. So can corrosion take place? No. So in the test tube B, we don't find corrosion. In the third situation, we are giving air. There is anhydrous calcium chloride which will absorb all the moisture present in the test tube. As a result, no water is available, but there is air present in it, oxygen present. So in test tube B and C, corrosion will not happen, whereas in test tube A we can observe corrosion. From this we can understand that for corrosion to happen, 2 factors are important, which are the air and moisture. Now we will discuss alloying. So what is alloying? Alloying means we are mixing a metal with another metal or a non-metal. Okay, so actually in pure form of iron we cannot make use of. Usually we feel iron as a strong metal, so we use iron for making so many articles. But pure iron, if you take, it is very soft, and on heating it will stretch because its elasticity is also high. So to make iron harder and stronger, we are adding 0.05% of carbon to it. So we get hard and strong iron. But carbon, is it a metal? No, it's a non-metal. So in this case, we are mixing a metal with a non-metal. Now, another way of making the iron more durable is making stainless steel. So stainless steel, what is the advantage? It is hard because nickel present in it will give it hardness. It is again preventing rusting because there is chromium also added. So it will prevent further corrosion, and also there is no stain, that is stainless steel. So actually we are getting many properties to this normal iron by combining with two more metals, nickel and chromium. So stainless steel has three components: iron, nickel and chromium. Compared to normal iron, it is hard and there is no rusting also taking place in this case. So how can we define alloy? Alloy means it is a homogeneous mixture of two or more metals or a metal and a non-metal. Here we found that properties of a metal can be changed by mixing it with other substances. The other substance may be a metal or a non-metal. So making alloy is a very good way of strengthening metals or protecting metals. What is alloy? Alloy is a homogeneous mixture of two or more metals or with the non-metals. So for this we have a primary metal. First we will melt that metal. To that we will add the other metals in a definite proportion. We cannot change the proportion. Proportion should be definite all the time. So we have a few examples here. When we make alloy, we take metal and non-metal or two or more metals. But one of the metals that we are taking is mercury. Then that alloy is called amalgam. So with the silver we form silver amalgam, and these are all mainly used, this amalgam is used in dentistry. So for filling the cavities or giving a cap to your teeth, they use this kind of amalgam. Then nowadays new technologies have come up. Traditionally this has been used. Next a few metals are, a few alloys are given here. Copper is a metal which is combining with another metal zinc, we get an alloy called brass. Copper if combined with a tin is Sn, okay, we get bronze, and lead if combining with the tin we get solder. So here in the first two cases copper is one of the ingredients. So copper is a very good conductor of heat and electricity, we know. But when we add zinc or tin to it, we are making an alloy, then that property of conductivity is getting reduced. They are poor conductors of electricity. The same way solder is when lead and tin are combined, its melting point is very low. As a result, we can melt them very easily. This is used for joining certain small wires and parts inside the electronic gadgets. So here, alloys are having low conductivity compared to metals. So if you remember in physics we learned the heating element of devices we are using alloys instead of metals. Why? Because it has got high resistivity, because their conductivity is also very less. Then they have low melting point compared to metals. So these are the important points that you have to remember in this chapter. Hope you understood the concepts very well. If so, please like, share and subscribe to my channel Biology My Passion. Thank you for watching.